Well, hi everybody. I'm back to dig in a little bit more using Tuner Pro RT on, in particular today, around EGR calibrations. Now, before your eyes glaze over, let me kind of recap just a couple things. First of all, if you're picking this video up and it's the first time, you know, I've got my 85 Camaro, 3rd gen IROC tuned port, and I started with a scan tool. There aren't very many of those out there, and I've got an Actron scan tool. Well, I wanted to dig a little further, so I got Win ALDL and a USB, an ALDL cable that goes to USB that goes into my laptop. Worked on Win ALDL, there's videos on that. Then I went to Tuner Pro RT version 4 because it seemed the simplest, and I got some data and have posted some data off my car on that. And then my last video was Tuner Pro RT version 5. I upgraded to that, and I was showing where you need to get, you know, that you need to get certain files, and if you want to understand what's going on, where you load the files and how you get rolling and what you look at. Now, today, I'm kind of going down one layer further, and this is specific to subscriber Mike, who is trying to get through emissions test in California. And he's got an 87 IROC automatic, and he's been having difficulty with passing the NOx emissions. And typically NOx will be one of two things. One of them would be catalytic converter not operating efficiently because of air pump or something along that line, or inappropriate EGR. And I kind of went, gee, you know, I look at my scan tool and my EGR goes up and down and goes all over. In fact, if I show off my Excel spreadsheet here, the gray is the EGR duty cycle, and it follows very nicely. Whenever I'm on the power, the duty cycle goes up, and it's you know, I can get 30%, 50%. I can get all kinds of intermediate points in there. And Mike says he gets 0 or max and nothing in between. And I'm kind of scratching my head going, that's kind of odd. Why would they do that? So now that I got Tuner Pro up and I found a place to get bin files and download them with examples from different model year cars, I'm going to go through those, and we're going to kind of see from model year to model year through 85 to 89, you know, what's in that calibration. The interesting thing is that the solenoid that drives the EGR system in this set of cars is a normally open system. And so if you don't have any power on it, it should have vacuum on it. So when you fire the car up and it's in park, the system needs to put a duty cycle on the EGR system and basically turn the valve off. The EGR valve is driven by what they call ported vacuum, which means at idle there shouldn't be any vacuum. The port is behind the throttle plate, so when there's a port, and when you crack the throttle, the port becomes open, and that's how you get vacuum to the EGR valve. And in the olden days, before computers, or if you have a carbureted engine, even in the 80s, many of them still operate with a mechanical with ported spark, and when you crack the throttle open, you get a little vacuum, it goes to the EGR valve, and the EGR valve opens up. And then they use temperature valves, thermostat valves, to keep it turned off when the engine was cold and so forth. And that's why the plumbing on the carbureted engines sometimes was pretty wild, because you'd have multiple thermal switches and in the EGR circuit. With electronics, that all kind of goes away. The third level in the EGR circuit is that this has what they call a negative back pressure valve, and on these cars, and that is when it senses negative pulsations in the exhaust system, the valve will vent and close. And so if you're at low speed, the throttle's not open, and you've got, you know, the exhaust manifolds always have pulsations in them. And so when those low pulsations, which when they'll go negative, will vent the valve. So it's really hard to understand how much the valve is open. Now Mike's told me he's even gone in with a camera underneath and watched the valve, and he can see it open and close. So we know it's working. The question is it working enough? One other wild card. Well, let me go one more. So this is how it looks like it worked. Now I'm going to go to my car, and we'll look at this one. So one nice thing about Tuner Pro 5, you'll see as I have stacked up here a bunch of windows, you can open multiple instances of Tuner Pro 5 at the same time. You can go over here in Tools, Custom Tools, and it says New Tuner Pro Interface, or Instance, I'm sorry. And you can basically use that and open up a separate window. So I've got like a half a dozen cars, a half a dozen windows all opened up at once. So here's my 85. And when I open up the table, EGR, duty cycle, RPM, and load, you know, at idle at 600 it's 0, but at 800 it'll go to 30%, and then it goes to 50, and then it goes to max. Now the one thing that's a little confusing to me, it may be semantics, it may be the way things are defined, but if this is a normally open valve, and you need to apply power to it, you need to apply a duty cycle to it to make it close, that's 180 degrees opposite to what you would expect. So for a while I was wondering, when it says EGR duty cycle, if duty cycle is 100% in technical terms, because of the way the valve operates, that ought to be driving the valve closed. Or in other words, as load and speed go up, the valve is being driven closed, if you did this literally. But I think, from what I see, is I think this is it's an issue of where you consider plus and minus. And even though it says EGR duty cycle, it's not EGR solenoid duty cycle, it's more like EGR valve duty cycle. It's like as power comes up, I'm driving the valve, trying to drive the valve more and more open. Now, one more oddity in EGR, in these EGR systems is, you can say I want it to be 100% and wide open out here, but the reality is that this valve is driven off of vacuum. And when you get to heavy throttle, there's no vacuum left. Your vacuum drops, your manifold absolute pressure comes up, and your vacuum goes down. And this valve will naturally close as you get hard on the throttle. New cars have electronically driven EGR valves, and they can be open at wide open throttle. But generally these vacuum driven ones can't. So this looked really fancy, and Mike also tells me he has a point where he has to run, I'm trying to remember off the top of my head, it's like 1500 and 2500 RPM loaded, you know, on a chassis dynamometer essentially. And he doesn't see, like at the lower speeds, he doesn't see EGR. Maybe it was 13. I don't remember the exact points right now. But he's thinking he's not getting EGR at those test points. Well, on mine, again, I'll go back to 85. If I go up to the scalars, this is where I picked this one up. So EGR on is right there. It's at 3.91, so 4% throttle. So it doesn't take much throttle as you just barely crack into the throttle. And once you get above 800 RPM, EGR is going to start coming on. As long as the negative back pressure doesn't turn it off, right? Interesting stuff. So that's my 85. If I go forward into 86, he has a 5.7 liter. I should specify that instead of a 5 liter. And so sometimes they'll calibrate, 5 liter and 5.7 differently. So here's the one for a 5. Now in 86 there wasn't a 5.7 Camaro. So I pulled a Corvette from 86, and using their definition file for a Corvette, I had an EGR duty cycle table. Why can't I find it? Oh, here it is. Here in the list, there's the EGR duty cycle table, and guess what? It is from 800 to 2000, and it's 100%. So basically this is like what Mike would say, which is I either get 0 or I get everything. So here's an 86 Corvette, and it's calibrated just to open up that valve and let her run full EGR, whatever vacuum allows. And the enable points are at, it's interesting on this one, there are 2 enable points. One of them's at 1.95 and one of them's at 3.12. And here's the, so if it's EGR duty cycle with an exclamation point, or if it's EGR duty cycle without an exclamation point. Now, earlier, in my last video in particular, I tried to explain that when you do these things, typically there's software, and these definitions are variables in the software, and then there are calibration variables that will feed the variables in the software and tell them what the operating is. So, kind of to recap, you got software in the controller that runs the engine, and it could run multiple different kinds of engines under that same part number controller, but your PROM will tell the software what calibration values to put into the software to make it run right. What should your idle speed be? It'll look at this chip, it'll take the value for idle speed and tell the software that's what I want it to idle at. And the software will say, oh, okay, and I've got a bunch of commands to do. So somebody built into this software a branch that's special, that says, under these conditions, I have a duty cycle with an exclamation point variable. I want the TPS to be lower. I want the EGR to come in sooner. And then here's one where I want it to come in a little bit later. Scratching my head a little bit, but so that's what an 86 Corvette looks like. Now, if I go to 86F car, this goes back to a 5 liter, all right? The 5 liter engine, which is what I have in my 85, it also doesn't, it isn't as abrupt as the 5.7. Maybe because it's smaller, don't know, but you can see at 800 RPM, it'll start coming in at 30%, and it'll kind of ramp up, and then it'll go max. So it's a whole lot more aggressive than my car is. And it's only one model year newer. And this one only has a single value for EGR on or not on, and it's at 5.86 TPS. So at 6% throttle, you tip it in, it's going to start coming up. And somewhere in here, presumably these controllers are loaded with the same software, but somehow it's being told through these different variables to behave differently for a 5-liter versus a 5.7, and to use this table differently even. I mean, I don't see the parameter in here for cycle or cycle exclamation point, right? So now I'm going to go to 87. Here's an 87 F car, 87 Camaro. 5.7, 3.27 axle ratio. And this ought to be what's in the IROC. And I picked one. There are a couple of different broadcast codes, but this is an ABWT. I think I looked at the other one and it looks similar. If you go through this definition in the tables, there is no EGR table. The EGR table is apparently calibrated out in the software, not being used, or it's hidden in some manner. But that's why I opened up that last one, because this is the standard XDF file for 32B, and there is no EGR table in the definition. And so then you go up to the scalars, up to the values on the top, and here's an EGR off and an EGR on. So it basically says turn on the EGR at 7.8% TPS, turn it off at 7.42. Enable EGR if you're above minus 17.5 degrees C. That's down around 0 Fahrenheit. So anytime you're above 0 Fahrenheit and above throttle, I think, I'm speculating, okay, and I know I'm speculating, but this would suggest to me that they took the table and calibrated it out, and it goes back to what we just showed a minute ago with the 86, where you had one with the Corvette where it just went, it was either 0 or everything. I think this is either 0 or everything. I think this confirms what Mike is seeing. I think it's correct. He's getting either no EGR at all, if he's below 7.81, or he's getting everything. So I'm going to hold that one. I'm going to set that to the side here a little bit. Here's a Vet, same year. This is this is the next year. This is an 88 Vet with a 307. And it's the same way, that in that mask there is no EGR table. In that XDF. Now maybe there's something missing from there, but this is what's defined as what it ought to be. And nothing there except an EGR on or off. And on the Vet, they bring it in at 6.25% TPS. A little less again. Here's an 89 Camaro. And it has a 6E XDF file. And in 89, they're back again with an EGR duty cycle versus LV8 and RPM. And here it is. It's back again. And at very, very light load, it would seem that it's turned off. and the rest of the time it's at max. So it's really following that trend. And again, you got the cycle or cycle and exclamation point variable is back in here. And it's either, so it's right around 6% throttle that you're going to get this enabled. And again, if the inlet air temperature, manifold air temp, is above, and it's interesting how they switched values, because this one's back to degrees Fahrenheit and 1/2 degree Fahrenheit, so again, down around 0. Then one more, and this is the 89 F-Car 5 liter, and it's very, very similar to the Corvette. It follows that same thing. Here it raised the temperature to 22 degrees Fahrenheit as the enable or disable point, and a little bit down here in the corner where they decided that you shouldn't have the EGR going, but then it goes to 99.7, so it's there. So I've gone through a whole lot of data, I understand. I kind of laid these out. So of all my summaries, I even looked at mine. I didn't show you that one. There was one with a 1F with an updated mask that was a little different, but the answer was the same. But you have, I'm going to go to the middle here, you've got 87 and 88 where the definition shows no table, and EGR on at separate points, and then the enables based on temperature. And in 88, I actually couldn't find a temperature either for the 5.7. So I'm going to look at, I'm going to look at this line item again. So I can't account for or understand, why the factory engineers picked where they did to calibrate things. And it could be, for Mike, it could be for calibration on this particular model that there's what you might call, there's a phrase called a calibration hole, where the calibration, there's nothing wrong with the calibration, but let me explain it a different way. In order to certify emissions, the Chevy guys, they're out at Milford at the Proving Grounds, they've got a big roll dynamometer, and they run the federal test procedure, city and highway. And they collect all of the exhaust essentially in bags, and then they analyze what comes out of the bags. And they collect all the carbon that comes out of the tailpipe and analyze it. Carbon and NOx and unburned hydrocarbons. And in order to pass, it's the emissions out of the whole test. So if you had a corner like 1400 RPM and a particular speed point and a particular throttle point where it gave just a little bit more emissions than you expected, it might dilute over the whole cycle. It might be a small part of the whole cycle. And yet, so the car may pass with flying colors, but in certain little spots, it may exceed what you would expect. So like California, they're doing a dyno test. They're not doing an hour-long, profile cycle and adding the whole thing up like we would do in certification. They're hitting 2 or 3 load points and saying, does your car pass at these different load points? And what I'm wondering, Mike, is 7.8 is a pretty high throttle value. And, I know how my Camaro runs with a 5-liter. It has a lot of torque. And your 87 with a 5.7 ought to have even more torque, right? And so the curiosity would be, if at the load points they're trying to hit, are you getting past 7.8% TPS? Or possibly, I'm speculating now, is your TPS out of adjustment slightly? Or could you skew it a little bit so that it reads higher? I know it's supposed, typically TPS is supposed to re-zero itself to a point. It's supposed to look at your zero value and adjust for a zero voltage, but I hate to suggest making adjustments, but I would be tempted to look at that. This is the biggest number I have seen. Basically 8% throttle to turn on the EGR is what it's saying. I look at the previous year, in a Corvette, and it's down at 3%. Later on, it's at 6 or so. I mean, that's... It could be that you're just very close. Don't know. My suggestion for today, I don't know if, I don't know how much that helps, but I think the answer is that what you told me in comments, that you either see 0 or max, I would say there's no table and you're getting 0 or max. And if there is a table, they've filled it with numbers to make it 100%. And that's how they want it to run. And then they're just depending on, the main thing should be your valve, when you're in your test point, your solenoid valve should be off so that full vacuum goes to the valve, and you get whatever, as you're tipping in the throttle, whatever the ported spark will do to drive the EGR valve should be what you get. You should get opening from that. Because I would say, as General Motors didn't calibrate in 1987 to whatever California was going to create sometime in the future for an emissions inspection test. And don't know the answer. You were concerned about back pressure and whether that has an influence, and I suppose it could. I don't know if there are any ways to modify, back pressure in the short term. I've seen some things like Borla where they do some orificing, more for noise than for back pressure, but there's a secondary effect of it. But in any case, that's what EGR calibrations look like in these cars. And Mike, I hope that helped you some. If not, send questions back. And it's to me, I look at this as a professional, I'm going to call it professional curiosity, that through my whole career, the goal has been to diagnose cars that weren't running right, or the engineered products that didn't behave the way we expected, and dive into the nuts and bolts and understand what was going on. So this is my next round of understanding what's going on, and I hope it helps.